Hello, everybody. Good morning, good afternoon, and good evening. And welcome to the second of a four-part webinar series on decommissioning, organized by the British Malaysian Chamber of Commerce's Energy Committee. My name is Sri from Scottish Development International, and I will be your moderator for today. So before I go into today's session, as your moderator, I would like to set the stage on how today's event came to be, and how is it that we're having this conversation, and what is this series part of, and what was the thinking behind all of this. So the discussion really involves three parties here. It is Petronas, Decom North Sea, and as well as the British Malaysian Chamber of Commerce's Energy Committee. So we had started this webinar on the 5th of August with our first series looking at P&A and facilities removal. And today, of course, we are looking at floaters, demob, and decommissioning. The underpinning thinking that the underpinning theme that looks at this entire topic is cost competitiveness and optimization, and looking at the industry now at this current low price. So before I go ahead and invite our guest speaker for Petronas, I would also like to acknowledge thank you to his team, who we've been working with in the background, and also the British Malaysian Chamber of Commerce's Energy Committee, and as well as the Decom North Sea. So with that being said, I would like to invite our first speaker, or opening remarks by Petronas, Encik Arif, who is the General Manager for Asset Decommissioning, Production and Operation Management, and PM Petronas. The stage is yours.
Thank you. Thank you. I hope everybody could see me and hear me well. Let me just start. Mr. Tim Martin, Vice President, Decommissioning, Action Integrated Solutions. Mr. Vin Bala, General Manager, Asia Pacific, Intermore. Our co-organizers in BMCC and Scottish Development International, Mr. Rohazwan and Mr. Sridaran Sabapati. Fellow colleagues from Petronas, production arrangement contractors, service providers, as well as representatives from academia. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to those in Malaysia. And for those in the UK, a very good morning. Thank you for your participation in this second webinar session of Decommissioning and Abandonment, an initiative by the BMCC Energy Committee, co-organized with Petronas, Scottish Development International, and Decom North Sea. As we are the new norm, due to restrictions caused by COVID-19, we are connecting via this virtual avenue. Notwithstanding, I believe this will not limit and hinder the cross-sharings to take place today. I am pleased to see that we could gather almost all PSC representatives from Malaysia, together with service providers and academia. A big thank you to everyone for making this happen. So for the past 18 years, we have begun various types of decommissioning projects for petroleum facilities in Malaysia, ranging from total offshore removal and onshore disposal, rigs to reef, removal of leased floaters, wells plug and abandonment, which includes subsea wells, and an onshore plant decommissioning. And today, now we see this pace steadily growing moving forward. For every executed decommissioning project, valuable experiences are gained. All these valuable learnings need to be reflected and applied in the future for, among others, cost compression, but more importantly, to ensure safety and preservation of human life, as well as the environment. Decommissioning presents significant opportunities for innovation, cost reduction, technology transfer, as well as development of regional skills and capabilities. In our efforts to revitalize the Malaysia EMP industry, and despite often viewed as something negative, we must acknowledge that decommissioning is upon us. With regards to our webinar's topic today, I would like to relate Petronas' own experience on floaters demobilisation and decommissioning, whereby to date we had successfully demobilised 4 floaters since 2014, including the most recent one in March earlier this year. Although we are not foreseeing as many floaters decom in Malaysia on a yearly basis as compared to the likes of Wells P&A, the challenges remain significant. Take the most recent FSO experience in March. The decom campaign required 5 anchor handling tugs and 1 construction vessel deployed concurrently, and the decom happened during the movement control order in Malaysia, where approvals and port clearances were challenging, to say the least, especially for foreign flagged vessels. Mobilization of construction and marine crew were very difficult, corresponding to the COVID-19 precautionary measures, as well as the newly introduced SOPs. Despite all the challenges, the operator had successfully towed out the FSO within 2 weeks from the field, Kuantan port, for subsequent activities, such as waste disposal, demarking, and laydown of recovered mooring chains, as well as the return of free issue items as per the FSO lease agreement. In our efforts to further compress overall costs, there were activities that were done prior to the FSO decommissioning, which topside flushing, vessels cleaning, terminal waste management, topside modifications for lighthouse mode, accommodation sharing, to name a few. In summary, the key success factors of the said campaign were proper planning and integration of activities into a single campaign, availability of as-built engineering drawings and documents, good coordination of marine logistics, and effective utilization of cutting technology for underwater operations. In addition, we also received good support from key stakeholders in terms of giving out permits and approvals. We are hoping that from this session, we can hear more on actual experiences of floaters decommissioning and demobilization from other regions, so as to gain more knowledge on technology advancements, industry best practices, and effective project management in managing floaters decommissioning. In the future, there will be more floaters to be demobilized in Malaysia, including tension leg platforms, spars, and floating production systems, both in shallow as well as deep water operations. Having mentioned an experience of a floater decommissioning earlier, we cannot stress enough that the costs and pace for decommissioning activities are being challenged by several uncertainties. This includes from the perspective of technical and technology, commercial, funding, as well as capability. With all these uncertainties, of the decommissioning journey, some are within our control, while others are beyond. The industry as a whole, including the government, as policymakers, operators, and service providers alike, shall continuously find best ways to manage and contribute in our quest to ultimately bring down costs and increase execution efficiency. Meanwhile, universities and academia could help the industry by embarking on research and studies, the results of which is hoped to lead towards cost compression and optimization of decommissioning and abandonment activities. Taking this opportunity by encouraging sharing among the various regions, it will be a chance for us, the Malaysia oil and gas industry, to listen, learn, expand our networks, and form collaborations. This is especially true on learning from past lessons, as well as technologies that could further improve abandonment and decommissioning execution, all in our pursuit of cost competitiveness and optimization in driving decommissioning and abandonment in the low oil price market. In closing my opening remarks, I wish to again thank you and look forward for an effective and fruitful sharing session in this decommissioning webinar. Thank you very much for your time. I wish the best of workshop for everybody.
Thank you very much, Arif. Thank you very much for your opening remarks. Hopefully that will drive the momentum into the industry. I've already seen the chat it's already getting lively, so that's a good sign that people are excited and people do want to have discuss this topic. So before we go into the main event for today, and which is the presentation from our two presenters, very typical housekeeping stuff. Everybody's aware of, everybody's been doing so many webinars now, so everybody's aware, mute your mic, no audio input and no video input as well. If you do have any questions throughout the session, just write them down at the chat box on your side, and I will pick it up and I will have them read out and have our presenters answer those questions during the Q&A session, which will be 40 to 45 minutes from now. So without any more delays, I would like to introduce the two speakers who will be presenting today. The first is Tim Martin, VP for Decommissioning at Action Integrated Solution. The second will be Vin Bala, General Manager, Asia Pacific at Intermore. So with that being said, I'll be back during the Q&A time. Over to you, Tim. The stage is yours.
And good evening, everybody. Good morning from wherever you are in the world today. This is the new normal, I think, of the decommissioning kind of sharing expertise and industry sharing. We all seem to be sitting in our houses, but I'm glad to say that Vin is actually sitting in an office today. So a quick introduction, I'm Tim Martin. I'm Vice President for Decommissioning at Action. I'll tell you a little bit more about Action and our integrated solutions business later. And Vin, if you'd like to introduce yourself, and then after that, we'll get started.
Yeah, sure, Tim, thanks. Selamat petang and a very good morning, everyone. My name is Vin Bala. I'm the General Manager for the Asia Pacific region of Intermore. Joined the company in 2014. I've been around for 6 to 7 years plus, mainly focusing on the floater segment, both on installation and decommissioning side of things. Thank you.
Okay, thanks, Vin. Yeah, we're delighted to be speaking to you today about our decommissioning experience and approaches and some of the learnings that we've had too. This is a business that we've been in for many years, and I wanted to just share a few slides with you about the Action Group, and then we'll talk a bit more detail. Vin is going to talk about our marine operations experience of removing floating infrastructure, and then I'm going to move on to just general decommissioning kind of mindset and some of the learnings that we've had and industry's had, certainly in the UK, over the last few years of the decommissioning market. So just to touch just briefly on our overall group, Action is a group that's based in the UK. Our head office is in the UK. We turn over about £500 million a year, and we have around 2,000 employees around the world. We work in oil and gas, in renewables, in aquaculture, and in marine construction. We are based in many of the usual kind of oil and gas places that you may expect around the world, from California in the United States through to over to Perth in Australia. So we were a group, I guess, we've been around for 20, 30 years, and we're made up of a lot of companies that you'll see maybe at the bottom of the screen there. There's about 21 different companies, and many of these that you may recognize. And I guess our strategy pre-2014 was to have these businesses being experts in what they do. I think we've realized probably since the downturn that we need to bring our company together a little bit more so that we can offer more all-encompassing services to our customers, because each of these individual companies brings something to the decommissioning table, and we want to bring that together to our customers in a single point of offering under our integrated solutions business, which I kind of run for the decommissioning segment. So we feel that helps our customers be more streamlined, it helps us be more streamlined, and we can deliver in a more effective manner for our customers, and ultimately, particularly for decommissioning, we can do that more cost effectively. Just to give you a highlight on our decommissioning track record, we've got significant experience from all around the world in decommissioning all sorts of things. From floating assets, we've removed now something like about 10 around the world in different regions. I'll show you where they are in a second. We've taken something like 650 subsea structures off the seabed. We've performed thousands of surveys of underwater assets, both pre and post decommissioning. We have very specialist cutting equipment internally, something like 100 proprietary tools inside to solve decommissioning challenges in the water. I would say that's on top of the water and underneath the water, subsea. And we've completed now something like around 3,000 individual projects. We work across the subsea, the floating assets, and the well space as well, and subsea wells in particular. And we've now removed around 200 wells, where we are now the market leader, definitely in the UK, at doing that. And we're doing that work rigorously, particularly. And we don't really own vessels, so we're not a vessel owner, but we bring a lot of smart thinking to those vessels. So we typically would charter vessels around the world, and we probably have something like 10 to 15 vessels around the world that we're chartering somewhere to go and carry out some kind of oil and gas capability. So in terms of floating decom projects, we've worked all over in terms of all the kind of major basins, particularly in Gulf of Mexico, West Africa, and Europe. We do have some experience in Asia, but predominantly, I guess, probably around the aging of these assets, as was just talked about in the introduction. It's something that's evolving, and potentially Southeast Asia is now starting to go on that decommissioning journey, whereas potentially in Europe, West Africa, and the States, we've probably been in that journey for a little while now. And I would still say we're learning. Absolutely, that's something key that I want to stress, is that I don't think we come to this presentation today, this webinar today, to say that we've got all the answers and we know everything there is to know, because I think the whole industry is still on this learning journey. We've got a presence in Southeast Asia, a big presence right across Malaysia and Singapore and Jakarta in Indonesia. We are based, all our different companies are based in these kind of different areas, as you can see, and we can bring the Actian overall integrated solutions to any part of the world that we need to deploy our services in. So I'm going to hand over to Vin now to talk about our marine operations experience. And then, as I said, I will then come back later on and we'll talk about mindset and learnings. So Vin, without further ado, I'll hand over to you.
Yeah, thanks, Tim. Moving on. So I will be presenting the marine operations, particularly with regards to the disconnect, laydown, and recovery, including the towing of the FPSO. So to kick off the slide pack, I'll be looking at the FPSO field infrastructure side of things, just to give an overview of the equipment which is to be recovered and decommissioned. So from an FPSO side, I think typically around the region, we are looking at, most commonly looking at FMX tankers, and going down, you've got the mooring line, which are pretty much, from a permanent mooring design basis, the guiding principles are under APRP 2SK, which defines the defining guidelines of the system, and you've got which consists of chain, spiral strands, and polyester. For shallower waters, with regards to the 100-150 meter range, we're typically looking at a full chain system for between 150 to about 400 meters of water depth. That's when you get spiral strands in, mainly to reduce the mooring line weight. Typically, it would be used in the likes of like China and Australia. And over for polyester, it's pretty much more for the deeper waters, about 400 meters, and that's to both for reduce the mooring line weight and also to mitigate the wave loads. For these semi-taut and taut systems, you want some form of elasticity, and polyester is a perfect fit for that. And when you come down to the anchoring points, it's a mix of items with regards to drag anchors, vertical embedded anchors, and piles. It typically depends on the mooring line tensions and the soils, which are the biggest contributing factor. Pile being the most accommodating with regards to soil, could be used on most of the soil types. And then from a riser and umbilical accessories, we have got one of the other Actian companies, 2H, which gets very involved in both the installation and decommissioning side for the analysis versions. And then from the subsea structures, you've got plams and plats, depending on what the field is from a flow assurance point of view. And moving on, we have got the different type of FPSO configurations. We have got the spread mode, the external turret, and the internal turret mooring systems, which include both the permanent internal turret and the disconnectable type, the likes of STP and STL buoys, which are more commonly used in the cyclonic environments, likes of Australia and China. I think for this presentation, we're focusing more on external turrets and spread modes, which are more commonly used around regionally in the Asia region. So I think when we start with the decommissioning side of things from an engineering perspective, before we move on and kick off on the project, the as-found subsea survey and the topside surveys are pretty critical and key. What you want to do is pretty much look at all the subsea structures, which we kind of highlighted, which includes the chain, water arch, and all the other subsea infrastructure, and also the topside infrastructure with regards to all the fairleads, holding points, strong points, and the support equipments like the pull-in winches, Smith brackets, etc. You wanna have a survey over them to see what's the integrity and the condition of them. That's key, and it's pretty much the key to coming out with the most suitable decommissioning methodology, which obviously links to the marine spread and equipment selection, which is the bulk of your course. And even though a lot of times decommissioning is always referred to as a reverse installation side of things, but it cannot be assumed as a normality, because from an engineering phase, you would always want to have contingencies after contingencies to kind of back you up and expect the unexpected kind of things. FPSO heading control from an external turret perspective, when you're doing the riser disconnect, you'll be looking at the heading control tab for an FMX tanker with the likes of about 60 to 90 tons, depending on the weather. For a spread mode, you could pretty much get away with any heading control then during disconnection of the riser. For the mooring chain disconnection, that could be in the likes of 2 on the bow for station keeping and 1 for stern tug. As compared to a spread mode, you could typically look at 2 tugs just for the station keeping, for the mooring recovery. I would like to touch base or speak a bit more on the one of the jobs we did for Benchamas for Chevron, whereby we got involved right from the planning stage. And when we're doing the feasibility and constructability study for them, we were looking at different options for the disconnection of mooring lines, including subsea cutting and all the other conventional ways. And one of the options which we proposed was using the station tugs to kind of move through the clusters, and using the bullet pole to create some slack, and using a long external torch to cut off down the external cantilever of the turret, which kind of got chosen off by Chevron, and we did the full detailed design for that. I think what we got as an outcome on that was we managed to save time on schedule wise, and also saved a lot of costs on subsea cutting and so on. And I think once the disconnection is done, the key is to get the floater pretty much offsite at the fastest point of time. That clearly tells you, gives you an example whereby you have got an FPSO out of sight and all the other relevant tugs associated to the FPSO out of field, which kind of saves you a lot of money rather than having all the other floaters in field from that perspective. So that's one of the optimizations you could have where you could save on. And with regards to towing, I would like to talk about the external turret towing. When you tow a ship-shaped structure by the bow, it's pretty common, and that's the way it's supposed to be towed. But the problem comes in when it's an external turret, and there are challenges with towing it from the bow, and then you have to tow it from the stern. And the biggest concern was around the fishtailing side of things. And again, on the Benchamas side project, when we did the tow of the FPSO down through the stern, we had to apply some principles around it with regards to tandem tow, which we had some concerns raised from the marine warranty surveyor, especially from a marine's perspective, and we had to justify that from a marine's perspective, and all the other scenarios which you can mitigate the risk from anything from a marine perspective of collision. We trimmed to the turret of 1.7 meters. And also during the analysis, we added a 30% additional drag force, which kind of specced up the tugs which are supposed to be towed. So if you just look at the bottom right figure, even with such considerations, we still had a bit of yaw, but this was much better than what we experienced from earlier lessons learned from other companies, whereby they tend to tow with one tug, and there was extreme fishtailing, and it became very difficult for the tug to control. Mooring chain decommissioning. So from this So from this segment, typically what you would have is a pull-in winch on the FPSO. It's just pretty much reverse installation, whereby you lower the mooring chain down, and then you would handshake it back to the installation vessel. That is in an ideal world if the pull-in winch is working, but a lot of times when you do a decommissioning of floaters, you cannot expect the pull-in winch to work or to function just with regards to the condition. And it's also challenging to install a winch on board the FPSO just with regards to it's been offshore and remote location and all the other complications around it. So cutting of the chain is pretty much another methodology to look at. And the engineered location for the cut is something which would go down right from the decommissioning phase, which goes back to your pre-survey, whereby you look at which is the best way to do that and to make a cut and for the recovery side of things. So some pictures from what we had before from cutting. So if you to see the top left picture, even though it's the chain which is pretty much on the seabed, we've kind of picked it up slightly so as to for the ROV to interface and for the cutter to be inserted through. And for the vertical cut, it's slightly easier just with regards to the placement of it and for slotting of the bandsaw onto the chain. One thing which I would like to highlight here is with regards to all the decommissioning scopes, if possible, things like SITs and trial cuts and whatsoever, they are key to be done prior to you before going on to the decommissioning campaign, which helps a lot with regards to any uncertainties and assurance. This is an interesting one which we've been seeing around a lot in Asia, whereby we have been asked by regulatories and operators and clients to have cutting of the mooring piles below the mud line. We have seen the ranges between -1 meter to -5 meters from that essence. And I think one thing which I want to bring in, it's not a new technology, it's been around. It's the internal pile cutter and the saber tool, which has been more commonly used in the jacket side, in the conventional jacket decommissioning scopes. Just on a cost comparison, if you have to use a diamond wire cutter just to excavate the soil out of the pile, you're looking at almost 36 hours per pile. That could potentially be about 13.5 days. But with these IPC and saber tool, they actually work from an abrasive water cutting system. You'll be looking at a dredging time of about 3 hours, and that's just a clear savings of almost 13 days roughly on a scheduled basis. And this tool so we've got a company called Claxton within the Actian group of companies which actually provides these tools. And for this purpose, it shows a clear savings in both costing and schedule. So for the riser decommissioning side of things, I think the installation sequence which I have is mainly a typical convention whereby you would be using a lowering method from either the FPSO or a subsea cutting from the infrastructure, either a PLAM or a PLAT in that instance, and then a pickup and recovery back to the main installation vessel. Something on here is from an installation perspective, if you delay buoyancy modules as such, you would probably require an overboarding chute whereby you would have to control buoyancy installation. I think how we have pretty much done is just to come out with an over arc that kind of save costs with both the installation site, and also it simplifies from a cost perspective as well. And the easiest way would be to get onto the reels. It just helps with the time spent, and then if possible, do the cutting onshore if it allows. Else, if you're going to be cutting it while on the vessel, there's things which you have to look at, like containment of the flow rates as such, which you have to pretty much look at from a more extensive basis. And one of the things that I want to bring up is for this Crito FPSO, we kind of came up with these subsea clamps. We designed and fabricated these subsea clamps, and these were installed prior to the decommissioning of the FPSO. And the main issues which we had when we did the topside survey was that there were integrity issues around the hang-off plate and the pull heads. So which would mean that we had to cut the riser below the hang-off plates. So what we did was we kind of had installed this prior us arriving in field. This was installed by divers, and we put on an internal seal plug. So we had 2 seals plugged for a contingency purpose, just to prevent any leakages. And the M-steel blue wires were passed on to the anchor handler, and once the cut was made, the load was transferred onto the anchor handler's winch for the laydown of the risers below the seabed. This was proper. It was a good system which we used, and the water depth which we had was about 400 meters. So typically, from a marine spread perspective, obviously for the marine spread, it's quite a key for the decommissioning costing model. You're looking at least 40 to 60% of the overall costing. There's no textbook example of you can use a particular vessel for a particular situation. It really looks back, ties you back to the decommissioning engineering and also what the requirement is with regards to the amount of equipment to recover and the regulatory side of things. One thing which I want to highlight is when you have got a mooring system in place, like with the FPSO, it is quite challenging to put another crane barge with another mooring system in place, because then again, you would have challenges with regards to line clearances as such. So, but then it becomes an ideal situation if we are able to remove the FPSO out of field and we have got the essence of time and with the recovery, and we have got the essence of time to recover the the materials as you move on, and cost-wise, it could potentially become a much cheaper solution. I am not going to run down the different items which you'll probably need from a decommissioning perspective, but one thing I would like to highlight would be the magnetic drill equipment, which we do have in our group as well, and this is typically used for a mid-water arch decommissioning. So what this tool does is to drill holes onto the mid-water arch, and then there's free flood of the mid-water arch to the seabed, and then the recovery is done. After which, I was chatting with Tim the other day, and he mentioned that there's another proven methodology which was done whereby the mid-water arch was kind of decommissioned by cutting off the tethers, and the mid-water arch just went off to the surface and was towed across. It's another proven technology whereby you can get away from all the heavy lift vessels by just using that method. And then the anchor handlers and the material barges and the associated project riggings and so on. I think what I want to highlight in this is the key drivers would be the offshore methodology and schedule, which comes back right from the start, from a pre-commissioning survey. As they mentioned earlier, from an Action perspective, we don't own vessels. So what we do is we work from a bottom-up approach, and we come up with the best solution if tying up with the technology and the equipment, and then go down to the spot market to get the most technically capable and cost competitive vessels, rather than working on from a top-down approach, which will be having a vessel and trying to get everything on down to that particular vessel just for utilization. Disposal is something which is becoming more and more interesting with regards to different constraints. There's a lot of stringent measures in there. So one particular thing which I mentioned earlier was about the riser recovery. So a lot of times, if there has been some requirements whereby the risers are recovered. So this would just typically be pinned back to the reels and then passed on to the operators. There have been occasions whereby they would not want to do that, and disposal is going to be under contractor, and that's when you have to tie in key things like marine growth removals and so on. Typically, anything, you would have quite a lot of marine growth from the sea level all the way up to 90 meters below. Anything below 90, you get lesser of the marine growth. So for shallow water projects, there's quite a lot of marine growth, and that has become a key thing. So, and then when you come to decommissioning and disposal, that's always become a concern. So it's either you remove it prior to decommissioning, or while you are picking it, recovering it up, you do the removal of it. I think the consideration could be probably which could happen would be right at the early stage would be if that could be done, if there's a possibility of getting everything done onshore, if possible. If there's an allocated yard, that would just save on the marine spread while being offshore and being involved in all the cutting and so on. The other way, for larger structures, you don't really want to tie up all your marine spread and critical path with sea fastening and so on. So I think it'll be much easier and better if all the grillage, if you could prefabricate, you could design and prefabricate grillages for the larger structures and work on a lashing system in order, which is going to be much quicker and easier from that perspective, especially for the mid-water arches and larger gravity bases and so on. And that would save up quite a lot of time for schedule and cost-wise. For the mooring chain, interestingly, we have seen quite a lot of requirements with regards to them being reused, especially from back to a marginal case perspective. So, so the straightforward way would just be to, once you recover high water pressure, remove the marine growth onto the anchor handler lockers, and typically when they are off to the quay side, they are normally put onto bundling and they are arranged back to passed on to the owners back again for the use. This is something which I want to touch base on. It's quite a special or interesting project which we have had, is the Red Hawk Spa. The pictures don't really do any justification to the size of it. So the spa is at least it's about 175 meters roughly. Just to give you a perspective, it's about pretty much half of what the Petronas Tower is. And this was probably the first reef to rig project, which we kind of did in the Gulf of Mexico. And we installed the Red Hawk Spa in 2003, and we went on and decommissioned her in 2013. Probably around the Asian region, this is not really very typical with regards to shipping channels and so on. But I guess this could potentially be considered, especially for mid-water arches. So instead of recovery back to the surface and to shore, probably we could look at decommissioning this and using it as a reef for the mid-water arches. So in that case, what we need, we won't really need any heavy lift vessels. We'll be looking at, we could potentially get a prefabricate a spreader bar and use the anchor handlers work wire for any shifting and tow it to a site for the reefing purpose. Yeah, so that brings me to the end of my slide pack, and I'll be passing on to Tim to carry on for his portion from a deeper decommissioning mindset.
Okay, that's great. Thanks, Vin.
Thanks,
I wanted to talk to you really around kind of mindset and some learnings that we've had kind of from other parts of the world. So in terms of, you need to obviously start the decommissioning process at the start. You need to set up for success, and I think some of those things that really can help towards that is really to think about not only the floating asset itself. There's such a lot of focus sometimes on what the floater looks like, what you need to do to the floating asset itself, but don't forget that there's always some subsea assets that are tied to it, either pipelines, whether they're rigid or flexible pipelines. And obviously, depending on if it's an FPSO, then you're going to have several manifolds and subsea trees connected to it. I think treating the whole subsea system and the topside system as one holistic decommissioning project is very important. We see that the way that operators are typically set up internally, having a topsides team, a wells team, a subsea team, that's kind of fine for projects and operations, but in terms of decommissioning, they don't necessarily understand what the kind of limitations of each other are. And I think sometimes that can lead to suboptimal and time wasting in the decommissioning process. So I think I'd recommend always that well ahead of the actual decommissioning process taking place, that those subsea wells and topsides teams share those skills and expertise and constraints that they work under. I think this can be invaluable in using the day-to-day field operational skills and bringing those together to create unconventional methods that ultimately will save a lot of cost. I'd also consider getting everyone sitting together. I know that's very difficult in these times in the COVID environment, but if you can think about ways to bring that team virtually together or ideally physically together to create that multidisciplinary team where people can talk about their challenges day to day from a wells perspective or a subsea perspective or an operations perspective. I think that's been very helpful in the past because you are generating solutions and answers in a very, very quick space of time. I think essentially as well, get the core crew involved, get the operations folks that are on that FPSO or on that FSO, get them involved early, and get their head around kind of those post-operations work scopes. So everybody's used to going offshore, doing their 2 or 4 weeks, whatever their rotation is, and coming back again. They've done it for tens of years potentially. I would stress the importance of the decommissioning process is not operations, it's decommissioning. I think you need to treat it differently. I think there's a different work mindset that people need, and potentially sticking by the book in terms of how we've done things in the past in an operational phase is not necessarily the right way to go. But we need to recognize that that can be very scary and very challenging for colleagues who have been used to doing the same thing in the same way for potentially several decades. I think the potential for major accident hazards is potentially much reduced in the decommissioning phase, and I think there's always a need to challenge each other around whether those major accident hazards are still relevant and suitable for a decommissioning phase as opposed to a decommissioning phase, as opposed to the operations phase. I think therefore that kind of leads you to a place that the technical standards for day-to-day oil production and operations, are they still really applicable? Ask yourselves, are they actually doing us any good here, or are they actually being a hindrance, and could they be relaxed, removed, or replaced with something that's more appropriate? So moving on, I believe that this is really around this term around a decommissioning mindset. So what is that exactly? Well, I believe it's about challenging everything and always being ready for change. So in decommissioning, we heard it just during the introduction, actually. I heard this term many years ago around, in decommissioning, cost is king. And it's amazing in decommissioning how often we speak about cost first, and then we talk about safety and environmental performance second, which is, I would say, the complete opposite of what we're all used to in the operations and projects world. I totally agree with that sentiment. I think it is all about the cost. Ultimately, it is a drain on a business to do decommissioning when there's not typically any return. But I think there's an inherent belief that, of course, we need to look after our people and we need to minimize our impact on the environment. And I think taking those learnings that we've all had from the projects and operations phase of a field life, we need to challenge we need to use that experience, but apply it and use it in a different way for decommissioning. I think additionally, always have a plan A. Vin talked about it just now. Have a plan A, but also have a plan B in case things don't quite go as planned. Oh, and by the way, you also might want to consider having a plan C just in case. So let me give you a couple of examples of kind of how we've challenged things in the past, and then I'll go on to discuss some lessons and considerations that you may want to think about for various stages of flow to decommissioning. So this is a project that we worked on previously. It's a typical FPSO with several subsea fields tied back to it. There were about 30 wells on this field. They were oil production wells. They all had artificial lift through gas lift, and they varied from 500 meters away from the FPSO to about 10 kilometers away. So there's quite a range of subsea infrastructure tied back to this asset. So the operator came to us and said, "Hey, listen, Tim, could you just check that we've done the right thing? We want to kind of go for FID here. We want to go for approval for the board for the budget that we've identified. We just want you to kind of rubber stamp this exercise and say, we've done the right thing, and can we check that it's, we've done the right thing here?" So they were looking at the flushing of the subsea system, and the typical way to do that, as many of you would be aware, would be to go mobilize a DSV and go and put a diver on the seabed, and before they can actually start intervening on the subsea system to start flushing. Typically, diving contractor would want to go and intervene on the trees to make sure that the trees didn't leak, that the well integrity was robust, and that the diver could safely start taking things apart on the seabed. Typically what would happen next is the flow line would be disconnected from the subsea well, and then a flushing hose would be deployed off the DSV down to that end of the flow line. The diver would connect the two things together, and you'd flush the flow line back to the FPSO, and you'd clear out the flow line back to the FPSO, and those returns would be processed in the normal manner on the FPSO. So typically that would take probably something around 24 hours to do, maybe 24 to 36 hours for each well. So over a 30 well program, you know, you can see that that's a 40 day program of work of a DSV. So we kind of approached it and said, well, you know, how could you do this differently? How could you maybe get rid of the DSV completely, and how would you do that? And when you start asking yourself those questions, you start to think very differently. So for those of you, I know there'll be a lot of technical folks on the phone and there'll be a lot of non-technical folks. So I'm going to give you a real quick lesson on subsea infrastructure. So this is your subsea Christmas tree. Gas is usually injected down into the reservoir, down the tubing, and it comes back up the production with the oil up the production side of the tree and out of the tree and down the flow line back to the FPSO. That's how a typical tree works. If you then move, if I can move the slide along, sorry. So we kind of suggested saying, hey, listen, you know, does the crossover valve, you know, usually it's shut. This crossover valve here, which joins the annular side and the production side of the tree, it's usually closed always. And we said, could you open it? And the kind of subsea guy looked at me and said, well, no, it's always closed. And the operations guy said, no, definitely, it's always closed. And I said, well, could you open it? Could you open it without actually deploying a DSV? And they said, well, that would mean overcoming our system subsea and overcoming our, you know, intervening and overriding the inhibits on the system. But yeah, we could open it if we really had to, but we just never have to do it because we're never asked to do it. So then we said, well, if you did that, could you put flushing water down the gas lift line, which we received a few quizzical looks around, you know, that's a gas lift line. We never put water down it. And we said, yes, we understand that, but this is decommissioning. You're never going to use that line again for any gas. So you could flush down the and they kind of got around it and said, yeah, we could potentially do it. We could put some water on top sides and flush down the gas lift line. That water would then go through the crossover valve and flush the production side of the tree and go back up the pipeline to the platform, or to the FPSO in this case, and we'd flush out the flow line. So essentially what that meant was some of the wells, 60% of them, more than half, could be flushed in this way, and essentially we'd remove the need completely for a DSV for those for the 60% of those 30 odd wells. That led to a £3 million cost saving, and additionally it reduced the COP post COP OPEX of the floater, because they could start doing this activity before the FPSO actually shut down. So that resulted in additional costs being saved when there was no money getting generated by the asset after COP. So another one is how clean to clean these pipelines too. How clean do you really want to get your pipeline? So there's this, I would call it an urban myth in the UK around this number, about 30 parts per million. So that's having 30 parts per million of oil in water. And if we reach that limit, we can say that the system is actually clean. Now, that number is generated by as part of the OSPAR, and OSPAR there's an agreement in Europe around OSPAR, as many of you know, that discusses discharges to the environment. So they say in a production environment, when you're putting produced water over the side every day, not decommissioning, this is just day-to-day operations in terms of water that comes with the production process, that water needs to be treated to 30 parts per million or better. That is where that number actually comes from. So these slides are a little bit small here. These numbers are a little bit small, so apologies if you can't read them, but I'll talk about them. So in 2018, the UK continental shelf achieved a average concentration of oil in produced water of 16 milligrams per litre, which is 16 parts per million. So good news, UK is doing really well in terms of emissions to the environment. We're about half of what OSPAR says. The associated water that went along with that oil was 139 million cubic meters. Now that is a big number, which is very difficult to get your head around. And essentially, if you do the maths there, what that ultimately means is that every year, or in 2018, we knowingly and approvingly, in terms of it was a regulated disposal to the environment, we put to sea 2,237 tons of oil into the sea. And that's perfectly acceptable. Everybody's bought into that concept, and that's totally acceptable to do that, because that's what we do every day. So Vin gave a little explanation of the Petronas towers. I think they're a very good measuring stick, so I'm going to use them too. So if you kind of put that 139 million cubic meters into the context of the height of the Petronas towers, and you formed a wall all around KLCC Park, which I've been to a few times, it's a beautiful place. How full would that tank be? If you made a tank out of the KLCC Park, how much water would you dump into that every year from UK operations? Would it be the height of the lovely shopping centre at the bottom? Would it be up to the kind of iconic bridge, maybe halfway up? Would it be all the way to the top? And this is where I wish I had you all in the room with me, because you could kind of put your hands up and you could show me who thought what. Well, actually, if any of you thought those numbers, you'd all be wrong, I'm afraid. So actually, that tank, if you made a tank out of the whole KLCC Park, it would be full of water of something like 690 meters tall. That's a lot of water. In terms of if that water had that 30 parts per million concentration in it, it would only be 10 centimeters right at the top if you could consolidate all the oil perfectly into one lump and the water into another lump. That would only be 10 centimeters of oil that would be at the top. So it's a very, very small proportion. So bringing it back to decommissioning, what does that mean? So if you look at the next 10 years, we're going to decommission something like 6,000 kilometers of pipelines in the North Sea in the next 10 years. I would say on average, the pipelines, it's a bit of a guess, but I would say on average, the diameter of those pipelines is about 10 inch. Some are very small, from millimeters, some are very large, up to 36 inches. But let's say on average, that's about 10 inches in diameter. So if you then clean those pipelines to 30 parts per million, the whole 6,000 kilometers of pipelines, you're only putting 0.75 tons of oil to the sea in that over 10 years. That's a one-off event. It's not every day. It's a one-off event. Whereas as an industry, we've already accepted that it's okay to put this much, much bigger volume of oil into the sea in terms of the production process. And that's going to happen every year for the next 20 or 30 years of life of the North Sea. So really, I believe we need to ask ourselves, are we trying too hard for this one-off event of decommissioning? Certainly we need to look after the environment, and we're not going to be reckless, but are these numbers challengeable? And I think that's where we're starting to come to. People are asking these kind of questions now in the UK around what is acceptable. Is it 30 parts per million, which isn't a rule? It's never been written down anywhere as a rule. Is it actually relevant for decommissioning? And that's, like I said at the start, these challenges are what we need to all do, I think, to really try and start looking at getting the costs down. And I think especially as the environmental lobby is changing, and Greta Thunberg's kind of view on climate change is moving along, then the harder we try to do something offshore, the more carbon we're putting into the environment from those operations. So it's really around, we're burning lots of diesel on ships and vessels and FPSOs to go and achieve these lower numbers of 30 parts per million. But is it actually really beneficial when you look at the overall environmental impact of the operations? So in terms of lessons to consider, I think definitely you need to be prepared. Everybody needs to be prepared. It's a good motto. If anybody was ever in a scouting organization, it was always a good motto of the scouts to be prepared. Always be ready for kind of what's around the corner. In terms of the timing of decommissioning, it's always so tricky because oil price goes up and down. When is the right time to stop? When does the field become sub-economic? It's really difficult to decide on what the right date is. I think in that scenario, obviously the floaters are much more easily removed than platforms, and I think that really lends itself to having this a ready-to-react plan. So could you pre-invest an amount of work, or could you do all the engineering work up front that you just put on the shelf, and when you need to use it, it's ready to go, and when the asset becomes sub-economic, if we have a crash like we've had recently, in terms of oil price, you can react much more quickly. And I saw a question in the chat earlier about kind of typical timing of FPSOs. Well, if you're ready to go at any stage on any day, then the timing of that FPSO demobilisation will be much quicker, and obviously the post-COP OPEX will be a lot lower. I think what we see in the UK this year in particular is oil price crashed in January, February time because of COVID, and there are now several, I think there's about 4 or 5 getting removed, FPSOs getting removed this season. That's bringing a lot of resource constraints. People are now scrapping about anchor handling vessels and getting access to vessels. And obviously there's an element of cost escalation that comes along with that. So the better prepared you are at any stage to react, that's the best that we can all do, I think, to lower the cost, to make sure you're going to deliver for low cost. I think I mentioned it before in terms of, you need to start at the start, but actually you probably need to look at what the end state is first. That's probably where you need to start. So you need to look at, is the vessel going to be recycled? Is it going to be reused? Are you going to choose these kind of points would ultimately, where that FPSO is going to be delivered to, they will really inform kind of what you're going to do offshore and how hard you're going to try to go and clean up and cut properly, depending on what the ultimate end point of the vessel is going to be. You need to consider where the destination port is, where it's going, what capabilities are in that port. Is it a specialist decommissioning site, or is it just a regular port that we're all kind of used to for any old boat? Because depending on what sort of facility you put it to, that will change the capability. And so if you went to a normal port, you would have to remove all the mercury, the norm, the hydrocarbons potentially, because the port can't handle those products. But if you went to a specialist decommissioning site, then maybe you can actually send the vessel there with all these things still in it, because they've got the capability to contain and process those waste streams from the decommissioning process. And then potentially, do you really want to actually do it yourself, or actually do you just want to hand this whole thing over to somebody else and give them the keys? We know that Petrobras in Brazil have recently done this. They've auctioned 2 or 3 of their offshore production units very recently, and they basically they're going from offshore. They've been given to somebody else to go and dispose of, and they can kind of not worry about the disposal of the FPSO at all. I think the kind of hydrocarbon freeing process, I would say that, it's great to kind of have a go while the asset's still operational. Don't wait for decommissioning to be upon you before you kind of start trying to inform yourself about what the right strategy is. So is the hull single skinned, double skinned? It's much more complicated to clean out tanks, cargo tanks in a single skin vessel with all the internal geometry of those tanks. You've got the man entry issues, you've got the HSE risk, you've got breathing apparatus. It just makes that whole thing a lot more challenging. Smooth walls on a nice double skin tank make the job a lot easier, of course. Have a go, have a go at something offshore about, how long is this actually going to take? If we bring this vessel back to a port, how long will this cleaning operation actually take of these tanks? I'm not suggesting you would clean the whole vessel as a bit of a trial, but you could certainly have a go at decommissioning a corner. You could have a go at some tricky structural intersection. You could do that offshore while the vessel is still earning money, because the rest of the FPSO is still getting used, or the FSO is still getting used for revenue generating activity. And these trials will help to inform you about how simple or complicated those end state operations need to be, and what those port facilities need to be. I think generally clients will tell us that they often underestimate the amount of flushing work that needs to be carried out, and they base it on shutdown activities or similar kind of operations where you need to clean, but you don't need to be really clean like you need to be for decommissioning. And I would say that generally they say that they underestimate the amount of flushing time. So having those trials, having those little practice runs while the asset's still operational, can help to determine what that timing is. And then additionally, obviously, when you're cleaning with water typically, or some kind of chemicals with water, but you're generating a lot of additional water that's got hydrocarbons in it, and they're not easily routed to the existing process system on the FPSO or the FSO. Treating that bulk water, treating that bypass, that cleaning water offshore, rather than putting it into a slops tank, and taking it all to port to be disposed of it offshore. There's temporary systems that you can take off to go and process that water offshore, and ultimately strip the oil out. So you're really reducing the volume of liquids that you're taking back to the shore. And you can ultimately then, you're going to pay a lot less to dispose of them when you actually get to the disposal site. Donor wells, you could consider those, of course, whether you want to actually put all that flushing water down donor wells. But that also brings its own challenges around, can the reservoir take those fluids? Have you got the right injectivity in the reservoir? Do you need additional pumping spreads, and have you got additional space for that equipment on the FPSO? And also, are there any contaminants or sand or those kind of other troubles in the subsea system that might actually block up the pores in the reservoir, and therefore not allowing that route to be continued? So I think it's kind of really important to also look at some different technology and try it out again during this operational phase. And I just wanted to show you a really short video, which Amy's going to just put on now, just to show you what some great products that we're kind of dealing with now. So this pipe is a perspex pipe. It's clear perspex. You can't see through it because inside it's covered with oil-based mud. It's pretty sticky, thick stuff, and you'll maybe see some of it. But when you pump this up, so they're pushing water through it now, and it won't take that stuff away. You put uptake through it, this fluid called uptake, which is a fully pumpable product, which is actually a cellulose-based fiber product. And you can see it completely cleans the inside of the pipe. There's nothing left. And it almost wipes the edge of the wall away. And then the actual hydrocarbons themselves are kept in suspension in that product, which is much easier to dispose of. And you can see that the rapid cleaning process that occurs when you use this product. And these are things that you could have a go at. And these are the technologies that we're working with the vendor who makes this kind of product, because we can see the potential it has for decommissioning. Amy, thanks for the video there. So riser disconnect, we talked about it a little bit more. Vin talked about it a little bit earlier. In terms of looking at the method to use, do you just want to cut them underneath the turret? Getting access to underneath the turret with diverless techniques is kind of tricky. You may leave long tails of the flexibles hanging down below the turret. And is the port deep enough to get those tails? Have they got enough clearance to get into a port to go and dispose of them? Do you want to just drop them on the seabed? Do you want to do that reverse install process? Vin talked about the challenges of that, where the winches and the strong points that you had when you install these flexible flow lines and the umbilicals aren't in place anymore. So subsea cutting's quick. However, those tails that you leave behind may really influence the choice of port that you need to go to. And then in terms of once you've removed the FPSO or the FSO, don't forget that there's, that's not the job's not finished, because there's typically a lot of equipment still left underwater, and that has definite risks for people. And we see when we remove those kind of visual markers of the FSO on the surface, that the other users of the sea are then very keen to get access to areas of the seabed that they previously weren't allowed to go in. We see that, and if you've got a lot of equipment that people aren't used to on the seabed that you've just left there temporarily before you fully abandon the field, that then potentially needs to be removed and dealt with. That presents a big hazard to fishermen if you leave it there, particularly who are trawling over that site. And obviously that would reputationally be terrible for us as an industry if something untoward happened to another user of the sea because of things that we hadn't really indicated to other users of the sea that were still there. And then the wells, additionally, obviously we need to make sure that they're secure. If they're not plugged and abandoned, we need to make sure that they don't leak, and potentially we may want to monitor those, we may want to look at them. And I'll show you now some technology that we're also working with that can help to monitor them. So I'm going to show you a little bit of a video first, and then I'll talk a little bit more about the technology after that. Okay, thanks again, Amy, for sorting out the technology there. That's great. So you'll be asking yourselves, I'm sure, what that was. What that is it's called an OPT, Ocean Power Technology Powerboy 3. The buoy is a wave energy converter, so it converts wave energy from the ocean and generates electricity. Essentially, that product can generate electricity, and once you generate electricity, you can power things with it. So this project really looked at, in the North Sea, looked at that case that I talked about of leaving abandoned infrastructure on the seabed and making sure that other users of the sea were protected from it. So this buoy had a camera on it. We sent this data stream live to the beach in Aberdeen, and you could look at the surface of the ocean. You can see the red thing up here is at the top of the screen there is actually the FPSO that you saw in the movie. And the buoy had a radar and vessel identification equipment, as well as cameras and both day and night, that it could identify and track vessels that entered the 500-meter zone illegally. They would then raise an alert, and we could contact the ship and protect and tell the ship that they weren't allowed into that zone. Additionally, as you're generating power with this system, you can also potentially power the subsea control system. So if you've removed the FPSO and you don't know what the status of the wells is anymore because you're not connected, you can reconnect to them with this device and monitor pressure, temperature sensors on the trees to really inform you around what the status of the wells is. And you can then have a great argument to the regulator to say my wells are still in good condition. There's been no change in the state of the wells in terms of the technical readiness of the wells, and therefore you can ultimately manage your decommissioning of the well process, the P&A process, in a more timely manner, where you can bulk and aggregate scopes together, and again drive down the cost of not only the platform decommissioning or the floating asset decommissioning, but also the well P&A as well. So I would just really kind of remind you about the slide we talked around. In decommissioning, I don't think we've got the right answer yet. I don't think we've finished. We're just at the start of this journey. And I would say if you go into it with that mindset of challenge everything and be ready for change, then your outcomes and your potential to reduce cost will be really great. And with that, I'd like to thank everybody for listening today. I really appreciate your time. I know it's late in some places, and I'll hand over to Shri, and we can have a Q&A session. Thanks.
Thank you very much, Tim. We are on schedule with maybe 5 minutes over. So without wasting any more time, maybe I can get Vin and Tim to turn on their webcam just for the Q&A. Yep. All right. So maybe we can go for the first one. So the first question is, and feel free to chime in and answer. Is there any specific rules or minimum requirements before a floater can be demobbed from its location or towed off-site? Example, does it need to be free of hydrocarbon, or just ensure safe disconnection with no spill, or hull tank can still be filled with sludge or oily content?
Yeah, no, that's a great question. I think, and it goes back to that point I made earlier around, look at your end states. What are you actually trying to do with a vessel once you actually get it to an end place? So, are you going to dispose of it? Are you going to recycle it? Are you going to reuse it? Those decisions should really inform around whether. What those minimum requirements are. So if you're going to go to a port and you don't have a specific decommissioning facility that can dispose of waste streams such as norm and mercury and hydrocarbons, then potentially you'd want to do more of that work offshore using the existing process system on the vessel, that you can actually go and spend the time offshore to dispose of those products and safely deal with them and dispose of them. If you go to a port that's got all those abilities to handle those waste streams, and pretty much you can just kind of, you can disconnect the FPSO and take it there. Once you take it to that yard, of course, there's a cost implication of having to dispose of those fluids. And if you go with a tanker full of flushing water and a slops tank full, and all the cargo tanks are filled with a mixture of kind of water and oil and slops from wells and all sorts of other potential places that it could come from. You've ultimately got to, the difficulty is you've got the that very complicated mass of all sorts of contaminants in the water, and you need to treat them onshore. And again, the potential to do that and having licensed and appropriate sites to dispose of that those fluids onshore is very difficult. So I don't think there's a particular answer. I think it depends on the context of that end state that you're looking at.
Okay, thanks.
It's a great question though, and it really talks to that my point, I think, around really thinking about what that end state looks like.
Thanks for that. The next question, I've had a couple of attendees ask the same question. So what is the best in-class timeline for floaters decom?
and please can we have it? So yeah, I talked earlier about several FPSOs getting decommissioned in the North Sea this year. That's happened. There's been, like I said, there's been about 4 or 5. I think they're going to be taken away this year, and some have been planned for a long time, and they've taken several, maybe a couple of years even to plan and think about. And other ones have almost just been dropped on the FPSO operator and said, by the way, we want to stop producing this field in 3 months' time. Get rid of your FPSO. So I would say, you can, if you're going through a planned process, it can take you 2 years. If you're going through we have to do this right now because commercially we are exposed if we don't do it quickly, then the reality is, I think the particular FPSO operator I'm thinking around, they were notified in about March in 2020, and the vessel will be removed, which we're involved in as a project, probably early next month. So 5, 6 months. If you really want to try, 5 to 6 months. However, there are some complications downstream that that haven't quite come to pass yet, because the mission is to get the FPSO off the field, to get the costs down, to get the people off. There's not really been a huge amount of thinking yet around the next steps of the decommissioning process, because just because the FPSO has been removed from the field doesn't mean the process has stopped. The vessel itself has to be either reused or recycled or repurposed or whatever that end state looks like. So I think I showed you a slide, in fact, of one vessel that was decommissioned in the North Sea last year. I think it was maybe 2 years ago. And that FPSO was planned. It was very, very well done in terms of the whole process was done. They waited really until the vessel got to the shore to clean it. And the plan was to clean it and then take it to another destination to go and scrap that FPSO. In terms of so it had to go on a significant sea voyage after that initial cleaning operation. They found the cleaning operation onshore was much more difficult than they planned. I talked about single skins and double skin FPSOs. It took a lot longer to demobilize that FPSO onshore. They couldn't really get it clean because it had to be clean and free of contaminants. And the only way to do it was almost cut the vessel apart a little bit, and they couldn't do that because the FPSO had to go on a sea voyage and it had to remain intact. So they tried very, very hard for many months, spent way more money than they were meant to, and ultimately sent it to a designated decommissioning yard where they could take it apart piece by piece and cut it and clean it, because that was really the only way to do it. So despite all that kind of good planning, that I guess that lack of vision on end state caused all those post-removal complications.
With reference to the last part of your presentation, Tim, what's the stage of the offshore monitoring technology, and has it been deployed commercially and proven? Yeah,
so I think the buoy I showed you was around probably about the 3rd or 4th one that's been deployed now around the world. They've been deployed in the Mediterranean, in the North Sea, and also in Southern America. So it's commercially available technology. It is available for deployment now. The system that we deployed was almost a trial. It lasted. We really was spent about 6 or 8 months offshore for a trial to see if it could really cope with the harsh conditions of the North Sea, which it did absolutely fantastically. It coped with all the kind of objectives that it was meant to, and we can use that. That is usable for other applications. So I think the way I like to think about it is it's like a big battery. Really, the big yellow thing we showed you it's like a big battery that never runs out. Pretty much you can power anything off that, and I think anything you want to power off that just becomes then a regular subsea engineering exercise, whether you want to monitor wells or whether you want to monitor something under the waves or on top of the waves into the general environment.
Yeah, I think just on that, I'd just like to touch base. So we are also working with the client down in Indonesia. So apart from the other monitoring, this could also be used potentially for military purposes. That's pretty much the project we're working on down in Indonesia, just to keep away fishing boats, illegal fishing boats. And then it's a pilot project with 2 and many more to come down the line from Indonesia. Yeah.
Thank you. Thanks for that, Vin and Tim. The next one is, a lot of these questions seem to be revolving around schedule. So how many days improve by having the external turret?
I saw the question. I guess probably I thought it would be easier to just answer live. So the external turret and the spread mode, the difference between both is one is stationary and one is weather vaning. The other one is weather vaning just because of loads and tensions, and that's why when it's weather vane, you got reduced tensions from that perspective. So from a construction perspective, spread modes are a much cheaper solution just from a conversion perspective. In a lead time perspective, because the turret itself could take about 6 months to fabricate and to install on. From a decommissioning aspect, it lies a bit further. There's more things to look at apart from other than the mooring as well. There's like risers, and also there's any diver work in there, which requires part of the regulations. So there's no straight answer to that, but I guess from a case-by-case basis, you have to look at it deeper and come up with the best methodology from a decommissioning perspective.
For that. Is there, so that this one is more towards regulation. I know from my conversation with a lot of the attendees for this session and other sessions is around marine regulation. So there's one question specific on that. Is there any regulation to remove marine growth offshore instead of onshore? The equipment enlisted previously to be used at offshore or onshore. So it's with regards to marine growth.
Do you want me to say that one, Vin?
If you can take that, Tim, yeah.
Yeah, sure. So I would say again, it depends on what where you're going to do that cleaning. So I think what we see in the North Sea is that things that have marine growth on them, you don't necessarily have to remove it offshore. Sometimes it's brought back to the shore. But when it gets dry and there's a nice sunny day in Aberdeen, which I hasten to add isn't very often, it can get pretty smelly. It can get very, very smelly. And because we're next to other stakeholders, other users, or the public, anybody who's been to Aberdeen knows the harbour's right in the middle of the city, and you'll basically spoil everybody's day because this stuff will be smelling very bad. So again, it's around thinking about reputational issues as an industry around what's the right thing to do. If you take it to a very isolated spot that isn't really going to impact anybody, then you can do it onshore all the time. I would say typically what's done in the North Sea is just as a best practice rather than a regulation. It's cleared offshore as much as possible, and then maybe some final cleaning when it actually gets to the shore.
This question is with regards to FPSO. How do you maintain FPSO within its excursion zone while each mooring line is being disconnected using anchor handling tugs?
Yeah, so we typically, both for external turret, I think it's one of my slides earlier. So anchor handling tugs, they're deployed for the station keeping purposes, while the main installation vessel is actually doing the disconnection of the mooring chains from the FPSO. The bollard pull required and the number would just go back to the methodology and the different type of configuration executed for the particular project. Typically, for an FMX tanker, for a heading control tug, you'll be looking at about 60 to 90 ton bollard pull. And for the station keeping ones, if you're looking at those to decommission, like what I explained earlier, for the Benchamas project, we actually use the station keeping tugs to move towards the cluster of the mooring line to reduce the tension, so that you could use a long torch of the external turret to make the cuts. It was not the prettiest sight, but then it was a much cheaper solution from a cost-effective basis, and from a schedule-wise, it was much better. But yeah, go ahead.
On the mooring line as well, there is, I guess, another question, but it could be a follow-up. After cutting off the mooring line, has there been instances where the mooring line is left on the seabed or in situ?
Yes, it has been, and that will tie back to regulation and the operator perspective with regards to what has been agreed and what was the original plan. So typically, they've either been left in situ. In some cases, we have also received inquiries whereby the operators regulation will want to do max excavation, whereby trench the mooring lines down, say a meter below, and including the pipelines as well. So we have done about, say, a meter to 3 meters below the mud line, so that they can do the seabed mapping. I think in some instances, it's been a bit more extreme with regards to they want to cut everything, say 1 to 5 meters below the mud line, and that would require more works. And that kind of ties into my earlier slide with regards to the technology, which could probably use to get away to save on costings from both a schedule and a costing impact.
Beginning of the session, there was a bit of a chat on by Arif on rig to reef. So there's a question on that. What is the requirement for turning jacket structure into reef? All structure can be turned into artificial reef. So.
Okay, so I would say from my point of view, obviously, it's always interesting to get a question about a jacket when you're having a floating presentation. So I think, again, it would depend on regulations. Depending on what jurisdiction you're in the UK, it's completely forbidden to do that. There is some more discussion about whether there's potential to do it, but the regulations say currently you cannot reef a structure. I know in other places, and I know it's already happening in Malaysia, there where the reefing is of assets are happening. It's completely down to local legislation.
Okay. So, sorry, Ben, you can share.
Yeah, I would just like that. I think I've kind of licensed at the regulators, and they have kind of said that the shipping channel, they just want to clear out the shipping channel, and they were looking at about 75-meter clearance from that perspective. So that's like a limit which they have, but then it comes back to the different regulations in the territories. Regards to what's been
okay. It's interesting you mentioned regulation. So there is a question on regulation. So I'll just sum it up in simple terms. Essentially, what is the differences in regulation you would think between the UK and Malaysia are, and what do you think the similarities are, and where do you think there are areas of improvement, or what do you think are best from the UK or some of the best practices here in Malaysia, just purely in terms of regulation?
That we could spend several hours on that question, I think.
So you've got 2 minutes.
Yeah, I'll be quick. So I think the clear difference really is, regulation in the UK is this clear seabed policy to remove everything, whereas Malaysia, I know there's the potential for things we just talked about, like rigs to reef, is definitely there. I think what we could all learn really in terms of between, doesn't matter what jurisdiction you're in, is around what's the right thing to do for the environment in the long term. There's certainly an emerging body of evidence that talks about the benefits of man-made structures in the ocean and the benefits that they have on the marine population. And I showed Greta Thunberg earlier. She's driving that debate to say the oil and gas industry needs to clean up after itself. However, by cleaning up after itself, we have to burn a lot of carbon. And if we're burning a lot of carbon to go and ultimately remove an ecosystem under the water that we accidentally put there, we didn't realize we were going to do that when we all started drilling and producing oil and gas offshore. It's just become a byproduct of the industry, and maybe it's a positive one that we need to really all truly get our heads around about what the right thing to do is. I think you're on mute. Sri.
So we've got about 4 minutes left. So maybe since the theme for our presentation in the webinar series we're doing is cost, so I'm going to try to close it by giving a minute to each or 2 minutes to each to talk about what are the unexpected costs that companies can expect to incur when taking on such work. So there's a lot of chat about unexpected costs and compressing costs, especially given the industry climate now. So maybe Tim, you could go first, and then you can chime in terms of what to expect in terms of cost when you embark on something like this.
Yeah, I think it is the unknown. I think that's decommissioning. I think it's that be ready for change. Those are the things when you're not ready. That's when the cost can escalate, because you've got no plan B, and you need to have as I said earlier, and Vin touched on it too. You need to have a plan B and maybe a plan C even. Once you have those, because you're not dealing with nice new facilities all the time. Things do go wrong, so things trip you up as you go, and I think being prepared for those, you can mitigate that cost overrun as much as you can.
Yeah. Yeah, I think from my end, and I don't expect to be a bit cheesy, but just expect the unexpected with regards to the decommissioning side, and again, it's just, I know I've said it a few times, but the pre-surveys and as such is pretty clear, and they are key to a lot of the methodology side. As a company, we work from a bottom-up approach, as I mentioned earlier, because we don't own vessels. So we tend to look at the most cost-effective solution and to go up from that end rather than doing the other way around. That's pretty much the key. And you just need to have backups over backups. And sometimes it's just safer. Whichever things can be done onshore with regards to installation sets or whatsoever, probably it's best you just do that and invest in that, so that if something fails, instead of having a marine spread on a critical path, which could be burning about 100K a day, you have got other contingencies to kind of look back into that and try to get these scopes clear. And decommissioning projects, and just comparing the installation side of things, it is quite challenging with respect to, Tim mentioned about recovering the products and the smell you get from all this marine growth, and especially from the shallow water, because they typically exceed the 0 to 90 to 95 meter range. It is quite challenging from that perspective. So the environment itself creates a lot of hardship and challenges. So when you go in for the decommissioning project, you have to be prepared for the worst case scenario.
Okay, thank you for that. And since we have 1 minute left for the Q&A session and for the session to finish, I am going to have to stop the questions here. There is a few more questions that needs to be tended to. So if you have posed a question and I have not asked that question, do not worry. We will have our presenters here write to you after the session. So we will channel the questions back to them, and they will be aware of it, and they will get in touch with you directly. Or if you have more questions to ask, you can either direct them to myself or Ro, and we will definitely convey the questions to them. So before I close the session, I would like to thank both our presenters. Tim, would you like to say final thank you and their details?
Yeah, no, absolutely. I'd just really like to thank Petronas and Decommissioning for kind of getting together and sharing knowledge. I think that's the key, is sharing this information. As I said, we don't have all the right answers yet. Nobody's a decommissioning expert yet, and despite what they might tell you, we're all still learning here. So I think the opportunity to share has been fantastic, and I just really like to thank everybody for staying so late. I know it's late in Malaysia right now, and really appreciate everybody staying late to listen, and thanks for your interest.
Thank you very much. Thanks. Thank you. Thanks to all those who are attending. It's about dinner time now in KL. I'm sure everybody will be getting ready to go for their dinner. And also special thanks to Petronas and EJRA for attending today's session, giving his welcoming remarks. So thank you, everyone. We will be having one for next month, and we will update on when and how will that be. Thanks again.
Thank you.
Great.
Thank you.
Thanks. Wish you a good day. Bye.
Bye-bye.